Alright, stat students, I wanted to go over a couple of these questions I handed out to you on Monday. Here it's from the 2000 AP Calculus AB exam, question number 6. It says, consider the differential equation dy dx equals 3x squared over e to the 2y. Letter A says, find a solution y equals f of x to the differential equation satisfying f of 0 equals 1/2. So go ahead and cross multiply. So go ahead and cross multiply on both sides here. You're going to get e to the 2y dy equal to 3x squared. So that's squared dx. And now we're going to integrate both sides of this to solve for this differential equation. And notice over here you're going to need to work with some u substitution. If you want to look at that real quickly, what I would do on that left hand side, I would let u equal to y, therefore du is going to equal 2 dy. So I'm going to need a correction factor. Okay, I'm going to need a 1/2 out in front, so I'm going to say 1/2 integral e to the u du. Turns out the right hand side, that works out pretty well. We can integrate this x squared pretty quickly. You're going to get 3x cubed, that's cubed, over 3 plus c. Alright, now we integrate this. The integral of e to the u is just e to the u. So that's 1/2 e to the u equal to 3x cubed over 3 plus c. And we can go ahead and simplify that. These two 3's are going to cancel. Now let's substitute back in our u. So our u here, see if I can get that to work. Our u up here is 2y, right? So we've got 2y up here. We're going to go ahead and substitute that back in. So I've got 1/2 e to the 2y equal to x cubed plus c. Now, we've got an initial condition. If you remember, I believe our initial condition was f of 0 equal to 1/2. So our y value is 1/2 when x is 0. So I've got 1/2 e to the 2 times 1/2 equal to 0 to the 3rd plus c. We're trying to solve for c to get a particular solution to this differential equation. So now I've got 1/2 e to the 2 times 1/2, that's just e, equal to c. So c is equal to 1/2 e. I'm going to substitute that back in, and I'll just put that back in over here. So I've got 1/2 e to the 2y equal to x cubed plus e over 2, or 1/2 e. Now what I can do is multiply everything through by 2. So let's just multiply both sides by 2. I'm going to multiply all of this over here by 2, and we get e to the 2y equal to 2x cubed plus e. So that's plus e. And in order to eliminate or to cancel out this e to a power, I'm going to need to take the natural log of both sides. So I'm going to need to take the natural log of that, and I'm going to need to take the natural log of this side. Okay, well, this is going to cancel, so I'm left with 2y, and I've got the natural log of 2x cubed plus e. And then I'm going to divide both sides by 2, or multiply. In this case, so I'll write it this way. I'm going to multiply both sides by 1/2. Okay, so I'm going to multiply both sides by 1/2 here. These cancel, and I have y equal to 1/2 natural log 2x cubed plus e. And now I've got that particular solution for this differential equation, f of x equals 1/2 natural log of 2x cubed plus e. Alright, so there's our solution. I'll sort of box that in blue here. That's our particular solution to the differential equation with the initial condition f of 0 equals 1/2. So that's the answer to letter A. If we scroll back up, we see that there was a letter B. Letter B said find the domain and range of the function found in part A. So we got to analyze this function just a little bit. I'll put this in green here. So we've got a function, this is letter B. We've got a function here, natural log. Well, natural log has a domain from 0 to infinity, but now that's the natural log of x. Well, we've got some stuff inside of here, so we need to figure out when 2x cubed is plus e is greater than 0. We got to know, typically this is x, right? If it was just a regular natural log function, well, that domain is 0 to infinity. Well, I need to figure out when this is greater than 0. All right? Well, subtract e from both sides, so you get 2x cubed greater than negative e. And then we're going to divide both sides by 2, so you get x cubed is greater than negative e over 2. And then, of course, you're going to need to take the cubed root. I'll go ahead and write that here. We've got to take the cubed root of both sides. So take the cubed root of all of that. So x greater than the cubed root of negative e over 2. That's my domain. That would be my domain for this function. Typically, it's x greater than 0. Well, in this case, the domain's going to be cubed root of negative e over 2, comma, infinity. All right, comma, infinity. Now, you may be wondering, well, what's the range? Well, the range of values this function can take on is actually any value. This function, if you think about the range for natural log, the range for natural log is negative infinity to infinity. Well, this function is going to be no different. So the range for this function, and you could graph this, throw it in Desmos, check it out. The range is going to be negative infinity to infinity. All right. The domain, we had to do a little work with it, but the range, it's going to stay the same as a typical natural log function. The range is going to be negative infinity to infinity. All right, let's look at our next problem here. We've got a problem, we got an acceleration of a particle moving along the x-axis at time t is given by our acceleration function right here, 6t minus 2. If the velocity, so we're talking about v of t here, is 25 when t equals 3, and the position is 10 when t equals 1, then the position x of t is. So we got to find the position function from the acceleration function given some initial conditions. Well, to find v of t, I'm going to need to find the integral, right, of a of t. So v of t, that's the integral of a of t dt, of course. So that's the integral of 6t minus 2 dt. What does that give us? Well, that gives us 6t squared over 2 minus 2t plus c. All right, so that's my velocity function. Well, I've got some initial conditions. So let's go ahead and simplify that, and let's plug those initial conditions in. Well, that's going to be 3t squared minus 2t plus c. Velocity is 25 when t is 3, so let's plug in 3 here. We got 3 squared minus 2 times 3 plus c. So that's 25 equals, I guess that's what, 9 times 3, 27, minus 6 plus c. Well, 25 equals 21 plus c. Well, what plus 21 gives us 25? C must equal 4. So my velocity function, v of t, is 3t squared minus 2t plus 4. Well, in order to get x, I've got to integrate that. To get my position function, I'm going to have to integrate 3t squared minus 2t plus 4 with respect to t. So we got to do another integration here. That's going to equal 3t squared over, 3t cubed over 3 minus 2t squared over 2 plus 4t plus c. Let's simplify that guy. That's t cubed minus t squared plus 4t plus c. Well, if you look at your multiple choice options, I think we're down to only one option left. T cubed minus t squared plus 4t plus c. Well, that's got to be this guy right here, letter C. If you want to find c directly, if this was not a multiple choice question, what you would do is plug in 10 and 1. So we would just say 10 equals 1 cubed minus 1 squared plus 4 times 1 plus c. Well, 1 minus 1 is 0, got 4. Subtract 4 on both sides, you'll end up seeing pretty quickly that c is 6. Okay, so c is 6. Our answer here is letter C. The x of t position function is t cubed minus t squared plus 4t plus 6. Okay. All right, let's see if we can quickly get through this last question here. I'll let you read that one on your own. You can pause the video. We're going to dive into letter A. Letter A says find v of t, the velocity of the particle at any time t. Well, the velocity is just going to be, v of t is going to be the integral of a of t dt, correct? That's correct. So that's going to be the integral of 6t plus 6 dt. And we're going to have 6t squared over 2 plus 6t plus c. So we've got 3t squared plus 6t plus c. Now they've given us an initial condition here. We said at time t equals 0, the velocity is -9. So I know this velocity is -9 when t is 0. So 3 times 0 squared plus 6 times 0 plus c. So c must equal -9 then. So our velocity function is 3t squared plus 6t minus 9. Now, looking at letter B, it says find the net distance traveled. So what would be the net distance traveled? That takes into account the sign of the distance, whether it be negative or positive. So we're just going to find the integral from 0 to 2. Since that's the interval that we're looking over, we're going to take the integral over this interval, 0 to 2, of v of t dt. Go ahead and pause the video. Why don't you do the work there? I'm going to pause, and then the work will pop up. Okay, you can see the work for letter B here. I just took the integral of our velocity function from 0 to 2. Got that antiderivative here, simplified, plugged into. If you plug in 0, you're going to get 0 because t is a part of each of these terms. Went ahead and evaluated, got 8 plus 12 minus 18 minus 0. Here's your net distance. Okay, your net distance is 2 units. All right, so that's our net distance. Now if you look up, we had one more question. Our other question here was find the total distance traveled by the particle over the interval 0 to 2. So let's look at that. I'm going to pull a different color up here. What we've got going on is we've got this integral that's going to need to be taken. We're going to need to evaluate this integral in two pieces, because we need the total distance from 0 to 2. We need that net, or excuse me, not net, we want total distance. So I want absolute value of the distance. I'm irrespective of sign, just everything positive in this case. Well, you need to set v of t equal to 0 to see where there's a change in velocity from negative to positive, okay? So go ahead and set up 3t squared plus 6t minus 9 equal to 0. Go ahead and factor that out. I'm going to pause the video. Okay, you can see where I've factored out the velocity function. I divided everything by 3. Factored here, I got t plus 3 times t minus 1. Well, the solutions to that are t equals 3 and t equals -3 and t equals 1. Only one of those is in my interval 0 to 2, 1. So from 0 to 1, this guy is negative. Okay, so I'm going to take the absolute value of that integral. And then from 1 to 2, I'm just going to take the regular value that's given to me as I evaluate that integral. So what I'm going to do is I'm going to set up this integral up here. We've already integrated, so I know it's t to the third plus 3t squared minus 9t. That's from 0 to 1, but I'm going to end up taking the absolute value of this guy. All right, so I'm going to take the absolute value of this here. And then I'm going to add that to t cubed plus 3t squared minus 9t from 1 to 2. I'm going to pause the video and then I'll have everything out there in just a second. All right, you can see the final calculations here at the end.